Hello guys, welcome back to lecture series on linear algebra. Myself Dr. Swapnil Shinde, and today I'm here with one of the fresh topic which is eigenvalue and eigenvectors. So this is the concept we are going to learn in our subsequent lectures. So before we start our main points, eigenvalue and eigenvector, I'm going to explain to you all some of the basic concept that are the prerequisites for our next point. Okay, so without further ado, let's get dive into our today's lecture. First of all, I will explain to you all what is the Cramer's rule, what is the synthetic division. These are the basic prerequisites we needed for eigenvalue and eigenvector point. Okay, this one is very much important point guys for competitive exam as well as final exams. Okay, so and it is very easy. Okay, yes, so without further ado, let's get dive into our today's lecture. Okay, so what is actually the eigenvalue? Eigenvalue is some sort of the scalars, okay, which associated with the eigenvectors. That one I will explain in my next lecture. Okay, first of all, we go understand what is the actually meaning of a Cramer's rule. Okay, so we already have learned Cramer's rule in our 11-12 standard for finding the values for unknowns like x, y, z. Such equations are there. Equation in a 3 variables are present, or maybe 2 variables. You can use Cramer's rule for finding the value solution for these 3 variable. Okay, or maybe 2 or more than 2 variable. Okay, so but now in my today's lecture I'm going to explain to you all a little different, like if whenever we have equation in a 3 variable but only 2 equations present, so in such a case how you can find the values for unknowns, okay, using Cramer's rule. So Cramer's rule, what it says that for finding finding unknown from our linear equations. Okay, for finding unknown from a linear equation we use the Cramer's rule. Okay, so our traditional method, when we have like equation in a 3 variable, 3 equations present, or maybe equation in 2 variable, 2 equations present, you can find out the d, then dx by d for the value of x, for the value of y dy by d, and for the value of z dz by d. This one is the Cramer's rule for equation, a linear equation in a 3 variables, okay, or 2 variables. So you can use this one. This is the like Cramer's rule that you all are familiar with. Okay, so I'm explaining here equation in a 2 variable, equation in a 3 variable, but only the 2 equations are present. Okay, yes. So for example, consider the equation. I consider here a11x plus a12y plus a13z, which is equal to 0. Okay, this one equation in a linear equation in a 3 variable. See that 1 variable, 2nd variable, and 3 variable. a11, a12, a13, these are maybe constants, okay, or scalars. Again, consider one more equation, a21x plus a22y plus a23z, which is equal to 0. So I consider here equation in a 3 variables. Okay, these are the linear equation in a 3 variable which are having constant coefficient a11, a12, a13, a21, a22, a23. Okay, so in this case how can we apply the Cramer's rule for equation in a 3 variable? Okay, yes, so Cramer's rule, it states that we write x divided by, okay, x divided by, so first of all we have to take this one into the determinant format, then we divide it into the x, y, and z. Okay, so we write x divided by, okay, again minus y divided by, these are the form of determinant, and z divided by. After divisions you will get some of the value as a constant. After this division you will get some as a constant k. Okay, so I consider this as a constant k. Okay, so for x we write a11, a13, a21, a23. Okay, we write a11. So this is the way we define Cramer's rule for the linear equation in a 3 variable for 2 present equation. Okay, so you can see that for the value over x we write x over the 2 by 2 determinant, which is a12, 13, 22, 23. for over y we take negative y over here, then a11 13 21 23. Okay, for the y we are taking these two constant coefficients, and for the z we are taking these two. Okay, so that means a11 12 21 22, a11 12 21 22. Okay, and which is equal to some constant k. Okay, so after finding these determinants, you just have to replace the value here, some constant, and take it to the other side. So you will get the k into some constant, y which is minus y which is equal to k into some constant, and z which is equal to k into some constant. Okay, for finding the unknowns x, y, z. So using this method, you can define the value for x. What is the value for x? You can define from here. Again, you can define value of y, and again you can define value of z. Okay, these three value you can define using this Cramer's rule. Okay, so I hope you all have understood what actually the Cramer's rule. Okay, so we have one more Cramer's rule. That one is also applicable. You can use this one. Okay, yes, but only when we have three equation and three variable. But two equation and three variable, that means quite confusing. Okay, yes. So I hope you all have understood Cramer's rule. We go for the next synthetic division. That one is also needed for our eigenvalue and eigenvector concept. Okay, so we go for the synthetic division now. Synthetic division. Okay, guys, you all have learned synthetic division from your 7th, 8th or lower classes onward. It is not that difficult, but synthetic division. Okay, so why we use synthetic division? We use synthetic division for finding the roots of our polynomial equation. Okay, synthetic division is mostly useful for finding the roots of our polynomial equation. Okay, maybe sometimes if you get the higher power like a third, fourth, fifth, sixth, in such case regular calculations are quite complicated. So in such a case we apply synthetic division to find out the roots. Okay, so let's get dive into our synthetic division. I'll explain to you all how the synthetic division work. Okay, synthetic division means the process of finding roots. Okay, let me write here for your understanding. The process of finding roots. Okay, the process of finding roots. So which roots? Polynomial, and we write polynomial as a f of d which is equal to 0. Okay, this one is like a form of polynomial. So we write the polynomial as f of d 0. Why f of d 0? Like we mostly use like a f of x as a 0 as a polynomial. Okay, but instead of x you can replace d, nothing matter. Okay, so obviously we want the solution or maybe a root for our equation. Okay, so you can replace x or you can replace d. We'll get the exact root. Okay, yes. So we consider, suppose that we have f of d which is equal to 0. Okay, and we want the root of our f of d which is equal to 0. Okay, so mostly we consider trial method. Okay, for finding the root we use the trial method. We use the trial method for finding the root. Okay, so for example, let me explain with one of the example. Okay, so we need to have example, we need to have some we are having some of the properties, but right now I'm not going for it. First of all, understand the example and then I will explain. Okay, so for example consider so here in this example I consider here d raised to 4 minus 2d cube minus 3d square plus 4d plus 4 which is equal to 0. Now guys, you can see that we have power 4. Okay, we have power 4 means you will get the 4 solution for this equation, but you can see that for finding directly the solution for this equation it is quite difficult. You cannot easily define the solution for these equations. Okay, so for that you have to apply synthetic division in order to get the solution. Okay, yes, so I'm having two standard steps before applying synthetic division. Okay, because see that the power fourth means you have to find out the one root first and then go for the third power of the equation. Okay, yes, so what we do here, we apply two methods. Okay, two steps. Step first, it is very easy. See careful guys, because this one is very important for finding the first root. Okay, if sum of all coefficient, okay, of our polynomial, which is equal to 0. What I have written in step first, if sum of all coefficient of polynomial is 0, coefficient means d raised to 4 is having coefficient 1, d cube having coefficient -2, d square having -3, d is having coefficient 4, okay, and it is called d raised to 0 is having coefficient 4, okay, constant 4 which is having d raised to 0, okay, d raised to 0 we write d raised to 0 is 1, okay, that means 4 can be written as 4 into d raised to 0, okay. Yes, so if we add all their coefficient and if the sum it goes to 0, we write d which is equal to 1 as a one of the root, okay. This implies d which is equal to 1 is one of the root, okay. Now find out the sum of all coefficient. How sum of all coefficient works? First coefficient is 1, d raised to 4 is coefficient 1, plus d cube has coefficient -2, plus d square is having coefficient -3, plus d is having coefficient 4, plus and d raised to 0 is having coefficient 4, okay. See that whether it goes to 0 or not, okay. So 1 -2 -3, so -2 -3 -5, 1 plus 4 5 is equal to 0, so we can write 4 not equal to 0. That means obviously d which is equal to 1, d which is not equal to 1 is root, okay. Obviously d is not equal to 1 is one of the root, okay. Yes, so if not is equal to 1 means we cannot define one of the root, so we have one more property. So our next step here, sum of alternate coefficient which all are equal, okay, alternate coefficient which are equal, then d which is equal to -1 is one of the root, okay. So let me write what are the coefficient we have present, okay. So we are having coefficient d to the power 4 as 1, first coefficient d to the power 4 as 1, second coefficient d to the power 3 as -2, third coefficient d to the power 2 as -3, next coefficient d to the power 1 as 4, and the last coefficient d to the power 0 as 4, okay. So we can see that we want the sum of alternate coefficient, that means this plus this which is equal to this plus this, but what about for extra number? We do not want that 4, okay, so that we have to reduce that 4 into the that 4 here, okay. So that means we have total 5 coefficients, so we want only the 4 coefficients, so we try to reduce this coefficient using synthetic division, so that we can easily find out the root d is equal to -1 whether it is possible or not, okay. Yes, so these are the all coefficient, okay. We are checking -1 whether -1 is a root or not, okay, whether -1 is a root or not. Let's apply synthetic division then, okay. So we take -1 over here, okay, then we use this bracket. This is the method that we use for finding synthetic division, and then later on we take this coefficient as it is here, 1 -2 -3 plus 4 and plus 4, okay. 1 -2 -3 plus 4 and plus 4, okay. This is the way we write this coefficient here, and plus whether we are checking whether -1 is a root or not, okay. Yes, so what is our next step? We are trying to reduce this one, so that once we get 0 over here, obviously we'll reduce into the 4, okay. So try make this last bracket as a 0 here, okay. So our next last target here to make it 0, okay. So we want 0 over here. So let's follow the steps for synthetic division. Okay, so what we do, we take 1 as it is down here, we are taking that 1 as it is here at down, okay, 1 as it is here. Now, so what we do, we multiply these two elements, -1 into 1 which is a -1, and we write this one here, okay, here -1, okay. So here -2, here -1, okay. And what we do, we add both of them, -2 plus -1 which is a -3, okay, -3. I hope you all have understood. Take 1 as it is here, multiply these two elements, take it here, again add these two, take down here, again multiply these two element, minus 1 into minus 3, which is a 3. Okay, minus 1 multiplied by minus 3, which is a plus 3. Okay, and add again both of them, which gives us the 0. Okay, 0 into minus 1, it is a 0, so take this 0 here. Okay, and add both of them, 4 plus 0, 4. 4 plus 0, 4. Okay, yes, we are adding both of them, we are adding these two numbers. Okay, adding these two numbers here, again multiply minus 1 into plus 4, what we get, minus 1 into plus 4 is minus 4, so minus 4 plus 4, it goes to the 0. Okay, so see that I got the last element as a 0. Okay, so now we have to convert this equation into the polynomial form. Okay, this one into the polynomial form, and we find whether the alternate coefficient is 0 or not. Okay, and if it is alternate coefficient 0, alternate coefficient equal, obviously we say that d is equal to minus 1 is one of the root. Okay, yes, it is very easy, guys. You can see also here 1 plus 0. Okay, sum of alternate coefficient, 1 plus 0 is equal to 4 minus 3 plus 4. Obviously sum of alternate coefficients are coming equal. Okay, so for that, first of all, find out the polynomial equation back. Okay, so what we write here, this one is the highest power, then it is smaller than the power, again this one is smaller than this, and this one is the d to the power 0. Okay, so that means we take this one for d to the power 0, d to the power 1, d to the power 2, and d to the power 3. We got the third power equation. Okay, so we write d cube minus 3 times d square. Okay, plus 0 times d. Okay, and plus 4 times d to the power 0, that means plus 4 only equal to 0. Now verify whether alternate coefficient, first coefficient is 1, second is minus 3, third is 0, fourth is 4. Okay, check out sum of alternate coefficient are equal or not. Okay, 1 plus 0, which is equal to minus 3 plus 4, minus 3 plus 4, you can write 1, which is equal to 1. So sum of alternate coefficients are equal, so obviously we say that d is equal to minus 1. This implies d, which is equal to minus 1, is one of the root of our given polynomial. Okay, polynomial of power 4. So we got the one of the root as a d to the power, for d to the power 4 as a d is equal to minus 1. So when we found the one root, so we have to take only the power third equation. Okay, so d cube minus 3d square plus 4, which is equal to 0. Okay, so our next task is a d cube minus 3d square plus 4, which is equal to 0. We have to find out the root of this equation. Okay, we got the power 4 as a one root. Okay, so as we have power 4 means 4 root, so once we receive one root, we have to take only the 3 roots from this one. Okay, yes, so we have d cube minus 3d square plus 4, which is equal to 0. Find out the root for this polynomial using again synthetic division. Okay, yes, d cube minus 3d square plus 4. So as we have alternate sum of alternate coefficient, is 0, so obviously minus 1 is one of the root, so apply minus 1 is one of the root for this equation. Okay, because this one is one of minus 1 is one of the root over here. Okay, so add these numbers here, d to the power cube is having 1, my d square is having minus 3, d to the power 1 is having 0, and d to the power 0 is having 4. Okay, these are the coefficient. So take 1 here down as it is. We apply synthetic division similar for finding the remaining root. 1 is as it is here, multiply both of them, minus 1, 1 into minus 1, minus 1, minus 3, minus 1, minus 4. Okay, again multiply this, minus 1, minus 4. Okay, minus 1, minus 4, plus 4, 0 plus 4 is a 4, 4 minus 4 minus into 1, minus 4. So take that minus 4 here, minus 4 plus 4, it goes to 0. Okay, obviously minus 1 is one of the root. Okay, so again apply next method over here, similar method, d to the power 0, d to the power 1, d to the power 2. Okay, so we got the again similar equation in a two variable. Okay, quadratic equation. So what we write, d square minus 4d plus 4 which is equal to 0. So this one is very easy to find out the root. Find out the number, their multiplication is 4 and their addition is minus 4. Okay, yes, so find out these two numbers. Okay, so we want the number that can use the minus 4 as addition and plus 4 as the multiplication. Okay, so equation, this one is a quadratic equation, guys. It is very easy to find out the root. Okay, our task is to reduce power third, power fourth, power fifth into the power 2. Okay, so this one you can easily find out the root. So as we have power 4, we got the d which is equal to minus 1 and minus 1, 2 root I found it here. Okay, so remaining one you can find very easily from this one. Okay, 2 roots from here. Okay, see that this one is our entire synthetic division method, guys. Okay, so for quadratic you can apply the standard method, minus b plus minus square root of b square minus 4ac upon twice of a. If the roots are complicated, you can find out the root using this one, or you directly go their multiplication 4, addition is minus 4. Okay, so it is very easy. I hope you all have understood, guys, synthetic division method. It is very easy. Okay, so you need to remember sum of all the coefficient, if goes to 0, then we write d which is equal to 1 is one of the root. If sum of alternate coefficients are equal, then we write d which is equal to minus 1 is one of the root. And if a constant term is not present, okay, one more remark you should add. If constant term absent, if a constant term absent, then we write d which is equal to 0, 1 of root. So see that we got the 3 important remarks for the synthetic division for root 1, root minus 1 and root 0. Okay, so later on, once you reduce our linear polynomial equation, so easily you can find out the root for a quadratic, cubic. Okay, that one is very easy. I hope you all have understood, guys, synthetic division and Cramer's rule. This one is our basic for our eigenvalue and eigenvector chapter. Okay, so even after if you found anything difficult, confusing, let me know in my comment section, guys. I will come up with a similar video. So thank you everyone. Thank you for my today's lecture.